This is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 5-2 in the SavvasRealize Algebra 2 textbook. So today's example, we are looking at rewriting the product or quotient of a radical. So when we are doing this, there's a couple of kind of key rules here. All right. The first thing to remember is that roots can be written as exponents. Okay, so let's remember that roots can be written as exponents. And so a lot of times these exponents are added together when we're multiplying here, right? So when I go to multiply here, okay, I have to remember that they have to have the same root. All right, so I'm going to make myself a little note here, okay? To multiply together roots, they must have the same index. And that comes from the fact that when you put it in exponential form, you can't add fractions that don't have common denominators. That's a thing, okay? So in this case, I have the same index, so I have the go-ahead to combine these underneath the same radical. Now, I can go ahead and, sorry, I got a little wild with my radical sign here. We'll tailor that back a little bit. But I can go ahead and multiply those like to 128. But I'll be honest, y'all, I would just be breaking stuff down again because that's how I do this. So in my head, I'm doing the prime factorization here, okay? 16 is 4 times 4, which means that underneath my radical, 16, and even change its color, would be 2 times 2 times 2 times 2. That's 16. And 8 is 2 times 4, and 4 is 2 times 2. So 8 is 2 times 2 times 2. So that green there, that's my 16, and the blue there is my 8. Now remember y'all from my last video that this index tells you how many of a kind you need to pull a number from the house. So this says that I need 5 2's to take this number from the radical. So I'm taking 5 of these 2's that are hanging out and kicking them out. Now inside my radical, there's still a set of 2 there. But because I don't have enough to take them outside the radical, I'm just going to multiply back together and just leave them where they're at. So this simplified to reduced radical form of 2 times the 5th root of 4. So for part B here, if I jump across my zigzag, now I'm looking at a problem that doesn't have the same dang radical. And I have to ask myself, ooh, what do I do? I might not know, right? And so generally what I recommend doing is putting them in exponential form. Okay, so that's what I'm going to do. So this 8x is underneath a 6th root, so I'm going to put it to the 1/6. All right. Now don't forget, you better put those parentheses, because if you don't, then only the x is to the 1/6 and your 8 isn't. So make sure to use parentheses when you put it in exponential form. And then I'm going to do the same thing with the other one. I'm going to try to keep them separate in color to help out. So that 2x is to the 1/3. Now remember, we want these to have that same exponent. Okay, so I'm going to look and see if I can convert those fractions into a common denominator, essentially. All right, so I'm going to rewrite that 1/3 as 2/6, because that is the same thing, isn't it? And I'm not touching that 1/6. This one's just staying the same. The red is. And so then I have to think about it. Well, there's a property. I don't really know the name of it, but it's just how to go from exponential form to to radical form. And it says you can write a radical like this, or you could write it like this. So the exponent can either be pulled into the parentheses or it could be outside. And it works for that root. Okay, so I'm going to split this 2/6 and treat it separately. Okay, again, the red one is just along for the ride. It doesn't care what's going on. But with the yellow, what I'm going to do is I'm going to take the 2x and I'm going to square it and then raise that to the 1/6. Because look at what happens. Now I have a 1/6 outside on both of these. And I can combine these bad boys into a 6th root. Okay, so all together, I have my 8x from the red, and I have my 2x squared from the yellow, all raised to the 1/6. Okay, so now I'm gonna try to combine all this stuff. Okay, so the 2x squared, I'm gonna distribute the square. All right, so 2 squared is 4, and x squared is x squared. Oops, got that 4 in my brain apparently. And now I can combine those. So 8 times 4 is 32. And then I have x to the 3rd to the 1/6. Now, remember, you always want to see if you can pull a number out of the radical. Because I'm going to turn this into a radical here in just a moment because it's asking for reduced radical form. But remember, that 32 came from an 8 and a 4. So 8 is 2 times 2 times 2. So there's 3 2's here. And 4 is 2 times 2. So there's 2 2's here. 2 2's. Not like ballerina 2 2's. I'm so funny. So there's only 5 2's in here. So when I go to write this as the 6th root of all this stuff, I know I can't pull anything out of the radical. So this is my final solution. Whew, that one was kind of a wild ride, wasn't it? Alrighty. Next one's going to be even more wild, alright? I'm going to give myself a little more room. So, remember how on our, I don't know, a couple of examples ago, we were saying you could split up a radical? If you have this division here, I could turn this into the cube root of 2 to the 2n over the cube root of 9m. Now here's the thing, y'all. You guys have often heard me talk about the radical kind of like it's a house. Here's a little tip I'm going to tell you. You cannot have a party in the basement, no matter how rad it is. That's how I remember this. Okay, so because I refer to it as a house, remember the denominator of that fraction would now be a basement. And I know y'all's mamas would not let you have a party in your basement, no matter how rad and exciting it is. You can't have a party in your basement. That's just like this. Okay, I cannot have some kind of root or radical in the denominator of my fraction. You go, well, Miss C, what do I do with that piece of information? Here's what you do. I'm going to tell you now. I'm going to multiply this fraction by the number 1. Okay, that's what this set of parentheses is. It's just the number 1. Because if I multiply something by 1, I'm not really changing it, am I? I'm just calling it 1. Alrighty, now that 1 is going to look a little funny, okay? Remember, whenever you have a number written over itself, that's the same thing as 1 as well, right? Like if I had 2 over 2, that's 1. Or x over x, that's 1. Alright, so when I have this number 1, what it's going to be is it's going to be some kind of cube root over itself, because I already have a cube root here. And the stuff that goes inside that cube root is whatever's going to finish making this into a perfect cube. Okay? So that 9 is the same thing as 3 times 3. So to finish this thing so that I could pull a 3 out, I'm still missing another 3. Do y'all see that? So I'm going to put a 3 inside of my little radical I'm multiplying by, because then I'll have 3 3's and I could pull a 3 out of that radical. Now if I keep looking, I have an m in here. Now in order to take the m out of the house, I need 3 of them, and I only have 1. So I'm going to add another 2 m's, or an m squared, into that house. Sorry, I shouldn't have said add. I should include or multiply that m squared inside that house. Because if I do 9m times 3m squared, I get 27m cubed, and that is a perfect cube for myself. All right, so now let's look at what multiplying by 1 does. All right. So up top, this is kind of the wild child up here, isn't it? So because I have that same index, I can just cram these all under the same radical. So I have 2 times 3, which is 6. I have an m squared, and I have an n. All right, so I just multiplied the stuff on the inside, and bam, that one's good. Now down below, what do I have? Well, I have a cube root of 3 times 3 times 3, so I have 3 cubed. And I have an m squared times an m, so I have an m cubed. And remember, when you take a cube root of something cubed, those just cancel out, don't they? So my numerator, he's chill. We're going to let him look how he's going to look. But down below, I'm taking the 3 out, and I'm taking the m out. And there we are. Now on more kind of wild problems, a lot of times there will be something that comes out of the top sometimes. Like it just so happens to complete a set upstairs, and you can reduce your fraction further. So be on the lookout for that. But that's our final solution. Now, the process we just did, it actually has a really fun name, which is why I'm going to use it. Makes me feel like I'm really smart. What we just did was a process called rationalizing the denominator. Doesn't that sound cool? I think that sounds cool. So to rationalize means to get rid of any roots or imaginary numbers. So we rationalized the denominator. I remember it as you can't have a party in the basement no matter how rad it is, because that's a wild thing down there, isn't it? Okay, so let's do some more examples. So here we are, we have another fraction. And in our heads we're going, oonts, 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 because there's that party in the basement. You see that? I'm going to break that up into 2 radicals. So I have the 5th root of 16x cubed. Down here, we have that party in our basement, so we need to multiply by the number 1. That's what I'm doing. I'm multiplying by the number 1. Okay? So I know that that number 1 is going to be some kind of 5th root over itself, because that's what my index is. It would be a pain in the neck to do a different index, right? So let's think about this. 16 is 4, or not 4, ooh, Lord. Well, I guess, 16 is 4 times 4. And if I break up those 4's, I get 2. So I get 2 to the 4th power is 16, okay? So inside of my 1 here, I need another 2 so that I complete my set of 5. That's where that's coming from. Well, what else am I missing, Miss C? Well, look at that. I have 3 x's. I need 5 to pull them out of the house, so I'm going to put another x cubed or x squared in there to complete that set. Alrighty, so now let's multiply it together. So up top, we're just combining that into a single radical. So I have a 5th root. 7 times 2 is 14. And then I have an x squared. Alright, down below, police are knocking. They're breaking up our party. Okay, we have a 2 to the 4th times another 2. That's 2 to the 5th. So our 2 comes out of the radical. And then an x cubed and an x squared. Together, that's an x to the 5th. And the 5th root of that is just an x. So there we are. That is the reduced radical form of that expression. And what did we do? What was that process called? It was called rationalizing the denominator. Whew, I'm sweating. That was exciting. All right, let's try another one, y'all. So now on this one, right, we want to multiply them together, but they don't have that same index. So we need to write them out as fractions in exponential form to try to figure out how to get the same index. Alrighty, so here we are. So that 4th root looks like a 1/4. And this square root turns into a power of 1/2. Now I can rewrite 1/2 in terms of fourths, right? I could call it 2/4, and that's what I'm going to do. And of course my laziness has to rewrite all this stuff. All right. And then we're using that little trick, remember, the power of a power property or whatever? Power of a product property, that one, the one I couldn't say. And I'm going to just take that 2 inside here. In fact, I'm just going to distribute that 2 inside there because I know it's coming. I know I'm going to need 2. Okay, so 3 squared is 9, and then x squared. And it's to the 1/4 power. Now those match, right? Twinsies. So I can put them under the same 4th root. So I have a 27. I'm going to get wild with it, get real colorful. That 27, which is 3 times 3 times 3. I have my 9, which is 3 times 3. And how many x's do I have? Well, I have 2 there and 2 there, so I have x to the 4th. And again, now we're looking for 4 of a kind, right? Because that's what my index is. So if you look right there, I have 4 3's, so I'm going to pull a 3 out. I also have an x to the 4th, so I pull an x out. And then I look back in my little house and I see who's there. Well, there's this 3 sitting alone playing World of Warcraft just like the rest of his friends. So that is our reduced radical form on that expression. So there you have it, y'all. That was kind of a longer video, mostly because of that rationalizing the denominator, but I hope that it helps out. Until next time.